In this part, we will dive into one of the most visible and fundamental physical structures in any warehouse: racking and shelving systems. In the upcoming slides, we will unpack the terminology, explore different types of racking and shelving, and discuss how they relate to different unit loads and picking processes. We'll also highlight how choices made at the racking level can influence the performance of an entire warehouse system, from throughput and space utilization to ergonomics and safety. We will look at both manual and automated systems, at pallet storage and tote storage, and we will also talk about hybrid concepts that combine different approaches. Throughout, we will consider the interaction between racking, load carriers, warehouse layout, and operational workflows. This module is essential for anyone involved in warehouse planning or operations, because getting the racking concept right is one of the key success factors in any warehouse project. Let's now proceed to define the terminology and clarify when we speak of racking and when we refer to shelving. On this slide, we take a closer look at the terminology used in warehouse design. When we talk about large units, and here we usually mean pallets or large containers, we speak of racks. Pallet racks are structural systems designed to support high loads. They are typically made of heavy-duty steel and they come in different variants: selective racks, drive-in racks, pushback racks, pallet flow racks, and so on. All of these are designed for the storage of palletized goods, often with access by forklifts or automated pallet shuttles. These systems are what most people picture when they think of warehouse racking. They are characterized by relatively wide aisle widths, high load capacities, and a modular structure that allows vertical stacking. Pallet racks can range from simple selective racks to highly engineered high-bay storage systems that reach 30 meters or more. Now let's look at the middle part of the slide. Here, we shift focus to smaller units, cases, boxes, or individual items. When these are stored in manual systems, the common term is shelving. Shelving systems are typically lower in height, designed for ergonomic picking, and they allow employees to walk or roll picking carts alongside the aisles to access goods. These are common in spare parts warehouses, e-commerce fulfillment centers, or farmer distribution hubs. Shelving systems come in many forms: static shelving, mobile shelving, inclined flow shelving, and many others. The key point here is manual access. Goods are stored and retrieved by people, not machines. At the bottom of the slide, we have small units again, but this time stored in automated systems. Interestingly, the term here shifts back to racks. Why? Because in automated small parts storage systems, such as mini-load ASRS or shuttle systems, the storage structure has to support a precise, standardized interface with machines. These racks are built to exact tolerances and equipped with features that enable robotic access. This may seem confusing at first. Why do we call it racking in one case and shelving in another when the item sizes are the same? The reason lies in the system characteristics. If a structure holds small items and is accessed by humans, we tend to call it shelving. If it is accessed by machines and has structural similarities with pallet racks, like fixed load profiles, standardized positions, and defined interfaces, we call it racking. So to summarize, pallets go into racks. Small items go into shelves if picked manually. Small items go into racks if stored and retrieved automatically. This terminology may vary slightly between countries and industries, but it's a useful framework. And it matters because it influences your discussions with vendors, your interpretation of technical specifications, and ultimately your system architecture. Before diving deeper into the many variants of pallet racks, let's take a moment to understand the basic terminology used to describe racking structures. The drawing on this slide illustrates a typical selective pallet rack and labels three fundamental concepts: bay height, bay width, and compartment. A bay is one vertical section of the racking system, defined by the space between two upright frames. You can think of it as a vertical column or frame within the racking structure. Most racks are made up of a number of bays arranged side by side to cover the full width of the storage area. So the bay is the repeating structural unit. Each bay contains a number of compartments, horizontal storage levels that can accommodate one or more pallets. In most systems, compartments are defined by the placement of horizontal load beams, which are adjustable and can be moved up or down to match pallet height requirements. The term compartment refers to the specific space between two load beams within one bay. So, in practice, the layout of a racking system can be described as a matrix of bays and compartments. Bay width refers to the horizontal span of one bay, which is typically designed to match the width of the pallets being stored. Bay height, on the other hand, is the vertical space allocated for stacking compartments, often constrained by ceiling height or forklift reach. Getting this terminology right is important not only when specifying systems, but also when calculating storage capacity, defining picking strategies, or planning warehouse layouts. In the next slide, we'll take a closer look at additional components that are often part of a pallet racking installation, many of which are driven by safety and regulatory requirements. This slide gives us a comprehensive overview of the structural and safety elements found in typical pallet racking installations. First, the safety mesh, mounted at the rear of the racks. These prevent loads from falling off the backside. Particularly crucial in racks that are adjacent to pedestrian walkways or workstations, a common regulation in many regions. Second, the upper crossbeam is a structural cross-bracing element that connects the tops of two racks. Its main purpose is to stabilize the entire racking structure. Pallet racks are subject to dynamic forces, from forklifts bumping into uprights, from asymmetrical loading, or even from seismic loads in some regions. An upper cross brace helps tie opposing frames together, preventing them from swaying or toppling. Third, the safety catch, a small locking mechanism that ensures the crossbeams stay engaged in their upright slots. Without this, forklift bumps or vibrations can knock beams loose, a major safety hazard. Fourth, the spacer, used in back-to-back rack installations to maintain alignment and safe clearance. In number 5, we have the frame extension. The frame extension, also called upright extension, in the context of pallet racking typically refers to a vertical add-on to the upright frame, extending its height above the top beam level. It separates bays on the top level of the rack, JB1. The side guards in number 6 are protective elements installed on the outer sides of racking rows, especially where the end of a rack borders a pedestrian aisle or drive path. They create a physical boundary that prevents pallets or goods from protruding dangerously into adjacent walkways. Simply put, they ensure pallets in outer positions don't fall off the rack. Number 7 shows the upright guard. These are robust, impact-resistant barriers mounted at the base of each vertical upright. Typically made from steel or polymer materials, they are designed to absorb and deflect collisions with forklifts or pallet jacks, thereby protecting the structural integrity of the rack. Damaged uprights can jeopardize the entire racking row, so these guards are an essential preventive measure. Similar with the double side guard, they are used when racking systems are placed in open areas with traffic on both sides. Protects both ends of the aisle from collision damage. The safe load warning notice in number 9 is mounted at the end of each racking row, specifying allowable loads by compartment, bay, and overall rack structure. This is critical for compliance and operational discipline. If you want to better understand why this is critical, I encourage you to go on YouTube and search for warehouse rack collapse and watch a handful of videos. In several videos, you can see that the racks are filled to the brink, and most likely the structural stability is compromised as a result. In these cases, a minor impact on the rack might be enough to let the entire thing collapse, and it might not even need any impact at all. The remaining elements in the picture probably don't require explanation and are not directly related to the rack structure. Let's now explore a specialized type of racking system, the cantilever rack. This type of racking is particularly designed for the storage of long goods. That includes items such as lumber, pipes, steel bars, panels, or extrusions, essentially anything that doesn't fit neatly onto a standard pallet due to its excessive length. If you look at the slide, you'll see two different visualizations. On the left is a schematic representation of a cantilever rack, and on the right, a real-world photo of such a system in use at a timber storage warehouse. Both images convey the core design principles of cantilever racking. The defining feature of a cantilever rack is the absence of vertical front posts. Traditional pallet racking has vertical uprights in the front and back of each compartment. In cantilever racking, however, there are vertical uprights only in the back, and projecting horizontally from these uprights are the cantilever arms. Because of this open front construction, long goods can easily be loaded and retrieved from the front without obstruction. In most cases, goods stored in cantilever racks are handled by forklifts, either front lift or side loading types. In specialized environments, overhead cranes are used. The open front construction allows the operator to position the load precisely, whether that means retrieving individual pieces or full bundles. The process is generally slow and deliberate, given the potential hazards of long goods. That's one of the trade-offs. Cantilever racking allows storage of goods that are otherwise very difficult to handle, but it rarely supports fast-paced picking.